Uh, Hello and welcome. In today's class, we will discuss about the projectile motion. So first, we know that whenever the acceleration is constant, only two kind of motion is possible. The first is motion in a straight line, and the second is motion on parabolic path. Motion on parabolic path. So here we know that when is going to be happen motion in a straight line. First, if here the initial velocity is 0 and the direction of initial velocity is along the line of acceleration, in this case the particle will move on a straight line. Except these two cases, in all other cases the particle will follow always parabolic path. Okay, say for example, suppose a particle is here at zero with zero velocity. It means it is at rest and it is acted upon by two acceleration. One is due to the wind 10 meter per second square, okay, and another is due to the gravity in downward direction, that is also 10 meter per second square. So we can say here the particle is at rest at t is equal to 0. So net acceleration acting on this body, on this particle, that is 10 root 2 meter per second square, and that is constant. So it comes under the first category. So on behalf of that, we can say that the particle will move on a straight line. Okay, in this way the particle will fall on this. So next, if we talk about the ground to ground projectile, if we talk about ground to ground projectile, so in ground to ground projectile, we'll see that, let's say for example, a ball is launched at an angle of theta with the speed u. Okay, a ball is launched at an angle of theta with the speed u. Here, if we are considering the vertical direction as a y-axis and this line as a x-axis, and from the horizontal the ball is launched at an angle of theta. This way we can say, we know that here the horizontal component of initial velocity, that is u cos theta, and the vertical component of initial velocity in along y-axis, that is u sine theta. So from here, when the ball is projected at an angle of theta, the ball will fall on the ground like that, something here. Suppose this is the initial point of projection and here the ball is falling down on the ground level. So from here we can calculate the time of flight, maximum range, and maximum height. Okay, this is the maximum height and this is your maximum range. So these are the terminology we'll discuss about that. So to find the time of flight, what we can do? Time of flight, time of flight. Okay, so to evaluate the time of flight, here we'll discuss. We know that what is the definition of time of flight? The time for which the ball remains in air before falling down on the ground, the time, that is called the time of flight. So to evaluate the time of flight, first we need to consider the vertical motion. Considering vertical motion, considering vertical motion, considering vertical motion, considering vertical motion, considering vertical motion. So here we have three equations of motion in which we are going to discuss. We are taking the second equation of motion, that is S is equal to ut plus half gt square, because this motion is under the gravity and it is an example of motion under 2D. So here, if you are taking vertical motion, Sy is equal to uy into t plus 1 by 2 zy into t square. Sy means along the vertical direction there is zero displacement. There is zero displacement here, and along y-axis the initial velocity, the component of initial velocity, that is u sine theta. Here u sine theta, and this is your time. Okay, the time for which the body remains in air. So in this way, 1 by 2, 1 by 2, and z. If we are taking here z minus, why we are taking z minus? Let's say we have sign convention. Here this is plus and this is minus. So from here we can say a u sine theta into t is equal to half of z into t square. So from here we'll get to t is equal to 2u sine theta by z. 2u sine theta by g. This is our time of flight. This is our time of flight for this diagram. Okay. So from here we know that very well. If this is our time of flight, so we can say in this time of flight here, the next again we are taking the same diagram. Here it is projected at an angle of theta with the speed u, and this is u sine theta. This is horizontal component, that is u cos theta. Okay. If we talk about the maximum height, if we'll talk about the maximum height, this is our h max. So how do we calculate the maximum height? So for this, we can do one thing. We are going to consider the vertical motion. So Vy square is equal to Uy square plus 2gh max. Okay. From here, Vy at the topmost points, we all know that at the topmost point, the body becomes horizontal. The velocity becomes horizontal. So here the y component of velocity at the topmost point is 0. So from this we can conclude that here if 0, we are putting here 0, and uy is u sine theta square, u sine theta square, and this way plus, and here again we are going to take the sign convention. In downward direction this is negative, and in upward direction this is positive. In upward direction this is positive. So here 2 and minus of g and h max. H max is in upward direction, so we can say that here from here u square u square sorry u square, okay, u square sine square theta, u square sine square theta, u square sine square theta is equal to u square sine square theta is equal to 2g h max. 2g h max. From here we'll get the value of h max. Formula for h max, that is equal to u square sine square theta by 2g. Okay. In this way we can find the maximum height attained by the projectile. Similarly, for this, we all know that this is the maximum height for projectile. Similarly, the third terminology, that is the time of flight, that is the maximum range, or range we can say, in horizontal direction. So we are going to discuss about the range. So if you're talking about the range in this way, if we are talking about the range, so to evaluate the range here, we know that we are considering the horizontal motion, horizontal motion to evaluate the range. Okay, to evaluate the range, which kind of range? Horizontal range. Horizontal range here. What about we are using the second equation of motion, Sx is equal to ux t plus 1 by 2 gx into t square. So from here we know that as in Sx, that is called the range. If we are taking this r is equal to ux is equal to u cos theta into t4, we know that the range is covered in time of flight, that is time of flight, and that is we got it already 2u sine theta by z, 2u sine theta by z. Okay, from here you know that, yeah, 1 by 2, and this gx is going to be 0. Why we are taking here gx 0? We all know that this is g, and in horizontal direction g cos 90. So the net acceleration, gravitational acceleration in horizontal direction is 0. So from here we are taking r is equal to u 2u cos theta into sine theta divided by g. So from here we are taking u, and again here u, another u. So we will get the formula for u, and 2 sine theta into cos theta, that is sine 2 theta. So u square sine 2 theta by g. This is our formula for range. This is our formula for range. Okay, good. Next, again, we know that very well. For this same range, we have two different angles. So how do we calculate the two different angles for the same range? Okay, we are talking about the two different angles for the same range. What we are going to calculate? Two different angles. Two different angles for the same range. So suppose first the ball is launched at an angle of alpha with initial velocity u. In this case, the range is r. So r is equal to what? We will write u square sine 2 alpha by g. Again, the same ball with same velocity but another angle, that is beta. On beta, at beta angle, it is launched. Then in this case, again we are getting the same range. So we can write here u square sine 2 beta by g. In this way, we have idea that the left hand side of both these equations are equal. In this way, we can equate these two. So we'll get here u square sine 2 alpha by g is equal to u square sine 2 beta by z. On solving these two, we'll get the different angles like that. Here sine 2 alpha is equal to sine of 1 180. This is 180 minus 2 beta. Why we are writing like that? Because we know that here sine theta is equal to sine 180 minus theta. Okay, so we can say that 2 alpha is equal to 180 minus 2 beta. So from here alpha is equal to 90 minus beta. Alpha plus beta is equal to 90. If these two angles are complementary to each other, okay, if the ball is projected in such a way that in different angles and the angles are complementary of each other, then we can say in that case the range will be same. Okay, similar manner here we can say in the next, suppose here what for the maximum range, for to be range maximum. Here we know that r is equal to u square sine 2 theta by z. R is equal to u square sine 2 theta by z. So from here r is equal to u square. R will be max when right hand side will be max. Here u is constant by which it is projected, and g is also gravitational acceleration, it is also constant, and sine 2 theta we can take it 1 here because sine theta can hold the maximum value, that is 1. So from here sine 2 theta is equal to 1 means, if sine 2 theta is equal to 1 means sine 2 theta is equal to sine of 90, 2 theta is equal to 90, theta is equal to 45, theta is equal to 45. So from here we'll get the formula for maximum rate, that is R max is equal to u square by z, u square by g. And at what angle will get the maximum range, that is 45. If we are launching an particle at an angle of 45-degree, then it will attain maximum range in horizontal direction. Or we can say if the range is fixed, then this velocity is considered to be minimum velocity, okay, by which the projectile is projected. In the similar manner here we can say the so we are getting the next topic, that is velocity at a general point. Velocity at a general point. Say for example, it is our x-axis, it is our y-axis. Projectile is launched at an angle of theta. It will fall like that here. Suppose at a point A. Okay. Okay. Here at a point A. Okay. This is point of projection. This is point where the particle is falling down. So from here, if this is u, so this is u, so will get, suppose the particle reached here at any general point. At any general point, the particle reached here at a point P. So what is the net velocity there at point P during the projectile motion? Let's say the particle takes a time t to reach at point P from O when it is launched at an angle of theta with velocity u. In this case here, if let's say here the velocity is v, okay, so its horizontal component, that is vx, and its vertical component, that is vy, okay. So let's say it is at an angle of alpha. So we know that very well here, if we are taking the horizontal component of, we are considering horizontal motion, so vx is equal to ux plus gx into t. Here vx at any time, at any general time, here ux is equal to always u cos theta. Here you know very well, this is the horizontal component and that this is u cos theta. Okay, u cos theta into plus, sorry, vx is equal to u cos theta plus gx. What about gx? We have all earlier we have discussed that this is 0. Why 0? It is in vertical direction g. In horizontal component of g, this is g cos 90. What horizontal component of g is equal to 0. So you're putting here vx is equal to u cos theta. Okay. So from here we are getting vx is equal to u cos theta. Clearly we are saying that this is independent of time. This is independent of time. No matter wherever the particle during the projectile motion, the horizontal component of velocity always remains constant, that is u cos theta. That is the initial component, the horizontal component of initial velocity. Horizontal component of initial velocity. Okay. Similarly, we can talk about the vertical component of velocity. So here, if we are considering the vertical motion, we are considering the vertical motion. We are considering vertical motion. Vertical motion. Here we have considered horizontal motion. Okay. So from here, Vy is equal to Uy plus gy into t. What about the vy? Vy is the vertical motion of vertical component of velocity at any general position. Okay, here uy is equal to what? This is the vertical component of initial velocity in y direction, that is u sine theta. Okay, so from here we can write here u sine theta, and always consider that the upward direction is positive and downward direction is negative. So from here this is z and t. So we'll get that the vertical motion depends on the time. Vertical motion depends on the time. Here, so during the half of the projectile, the vertical motion decreases, vertical velocity decreases, and during the next half, vertical velocity again increases because of the gravity. Okay, similar manner we can say here, what about the net velocity? The vector form of net velocity we can write here vx I cap plus vy j cap. So from here we'll get v is equal to u cos theta I cap plus, sorry, yes, u cos theta. Here it remains always constant. Okay, and what about vy is equal to u sine theta minus zt into j cap. Okay, so next if we'll talk about here at the general position, what is the value of this alpha? What is the value of this alpha? So to evaluate the value of alpha, we can do one thing. What we can do? We can do here. Here, and we know that very well, the tan alpha is equal to, what is the value of tan alpha? Tan alpha is equal to Vy by Vx. So what about the tan alpha? Vy is equal to, what about the Vy? Vy is equal to u sine theta minus zt. U sine theta minus gt. Okay. And here the Vx is equal to u cos theta. So from here tan alpha is equal to u sine theta. What about the u sine theta? Here u sine theta minus gt. Okay. So we can do one thing from here. Yes. If we are going to take an question take a question, if you're going to take a question here, if after what time, the from the point of projection, after what time the projectile will make an angle of 45 degree. So for this we'll have to put here, we'll have to put here okay, we'll have to put here 45, we'll have to put here 45 degree. So we'll get from this u sine theta minus gt upon u cos theta. If theta is the initial angle of projection which is known, and you will also be known, g is, suppose g is 10 meter per second square. So from here we can get the value of time after which the projectile will make an angle of 45 degree. In the similar manner, we are talking about the trajectory. What is the trajectory of projectile? Okay, so here to get the trajectory of projectile, here suppose this is trajectory of projectile. One another question, we are going to take another question. Suppose here question, if a ball is projected at an angle of theta with the speed u, okay, and this is your y-axis and this is x-axis, after what time, the question, after what time the final velocity will become perpendicular to the initial velocity? Say for example, if the particle is projected from here and when it will reach here, and at that time the particle's velocity, the velocity of this particle is perpendicular to the initial velocity. To how to solve this problem? To solve this problem, first we know that the vector form of equation of motion, that is v is equal to u plus z into t. V is equal to u plus z into t. So from here v is equal to u plus z into t. Here we know that this is your velocity u, velocity vector, initial velocity vector. This is your horizontal line. Okay, and this is your gt vector, vector g into t. And here the resultant of these two, we know that this is final velocity. So resultant of these two, this is final velocity. And here it is given that the projectile is launched at an angle of theta. So from here, if this is theta and this is your horizontal and vertical, means this angle is 90 degree. Okay, so from here we can say, if these two velocities are perpendicular, if these two velocities are perpendicular, so we know very well in vector chapter that if two vectors are perpendicular, then dot product of these two vectors must be 0. In this way we can say here, in this way we can say the dot product of these two vectors must be 0, and that is okay, the dot product of these two vectors must be 0. So we can write here u dot b v must be 0, u dot v must be 0. So from here u is the initial velocity, and here v is equal to u vector plus z vector into t, that is equal to 0. So taking the dot product, u dot u plus u dot z into t, that is equal to 0. So from here what we can conclude, that here u dot u is equal to u square plus here u into z into something cos theta. But what, how we can calculate the angle between these two vectors? So this is your u and this is your z vector. In this way, this is the angle between these two. If this is 90 and this is theta, then this is 90 minus theta. Okay, this is 90 minus theta. And what about this? This angle must be 180. So this angle would be 90 plus theta. Yeah, 90 plus theta. This angle will be 90 plus theta. So we'll write here ug cos of 90 plus theta. 90 plus theta into t, that is equal to 0. So from here we can say this u will be cancelled out. By this, if we'll divide throughout the equation by u, here u plus z cos 90 plus theta is equal to minus of sine theta into t is equal to 0. So what about the t? U is equal to g sine theta into t. From here we'll get the value of t, after which the final velocity, after which the velocity will become perpendicular to the initial velocity, after which the velocity will become perpendicular to initial velocity. So from here t is equal to u by g sine theta. This is our expression. Okay, after that, after which the particle will get an velocity, okay, which is perpendicular to the initial velocity. So we will talk about the trajectory of projectile. Trajectory of projectile. How will calculate the trajectory of projectile? So to calculate the trajectory of projectile, we all know here, here time is the common parameter. Time is the common parameter. Say for example, this is x and this is y. Okay, this is x and this is y. So time is the common parameter. If this is launched at an angle of u with at an angle of theta with initial velocity u. So let's say, for example, at any general point, the projectile reached at a point of P, at a point P, and it has a velocity v, and its coordinates are x comma y. Okay, so this is your horizontal displacement, that is x, and this is your vertical displacement. This is your vertical displacement, that is y. So again we are going to consider the vertical motion and horizontal motion. So you know very well here, if we are talking about the horizontal motion, we are talking about the horizontal motion. We are talking about the horizontal motion. If we are talking about the horizontal motion, what we'll get here, Sx is equal to uxt plus half of g into t square. Here t is what? T is the time taken by the projectile to reach from point O to point P. So Sx is equal to what? X. Ux is equal to what? Ux is equal to u cos theta. Always remember, it is independent of time. It remains always constant. That is u cos theta. And here time to reach from O to P, it will take time t, and in which it is traveling at a horizontal distance of x. From here 1 by 2, and g in horizontal direction already we have discussed, that is 0. So from here x is equal to u cos theta into t. This is our equation number first, let's say. In this way, next again, if you are taking the vertical motion, considering vertical motion, considering vertical motion, considering vertical motion, if we're considering what's vertical motion, what will get? As y is equal to uy into t plus 1 by 2 zy into t square. Again the same concept. Here this is minus and this is plus. What does it mean? In upward direction all the parameters will take with positive sign, in downward direction all the parameters will take with negative sign. So from here sy is equal to what? Here when it reached at a point of P, then the in this case the vertical displacement is y. And what about the uy? Uy is equal to u sine theta. U sine theta. So from here u sine theta, u sine theta. Okay. Okay. U sine theta into u sine theta. U sine theta into t, and plus 1 by 2 minus of g into t square. Minus of g into t square. So from here we will get y is equal to u sine theta into, if we're taking the value of time from the equation number first, so we'll get from here t is equal to x upon u cos theta. T is equal to x upon u cos theta plus 1 by 2, and here minus z into x square by u square cos square theta. So on solving this, we'll get sin theta upon cos theta, that is equal to tan theta. U will be cancelled out. So y is equal to x tan theta minus, from here we'll get z x square divided by u square cos square theta. This is our the equation of trajectory. This is our equation of trajectory, and we can solve it. We can make it in terms of range. Okay, how do we get it in terms of range? So we'll take it in another way. Okay, so y is equal to x tan theta minus z x square. Here you know what is the formula for range. Formula for range is equal to u square sine 2 theta by z. How will get the this formula here in this expression? So here we know that here cos theta is given. Okay, so to find this equation in terms of range, dx square, here we have u square, here cos square theta. If we'll multiply this cos square theta into sin square theta in upward or in numerator also with sin square theta. So from here and with the 2 here with the, okay, 1 minute, let me explain again. Mm, Here already we have 2 in the expression. Already we have 2 in the expression. So from here we'll get here 2. Yes. So if you're getting 2, so yeah, again, if here 2, then we have multiplied by sin square theta. So what we'll get here, if we're taking here cos is sin square theta into cos square theta into 2 sin theta into cos theta, that is sin 2 theta, sin 2 theta. So from here y is equal to x tan theta minus g x square, and here sin square theta, sin square theta, yeah, okay. So finally we'll get it on solving this in terms of range, in terms of range, in terms of range we'll get to, in terms of range we can find it like that, y is equal to x tan theta common 1 minus x by r. If we'll put the value of r here, we'll get the same equation, we'll get the same equation. Okay, so thank you, today's class.